Hey guys, welcome to Mind Your Maths. So in the series of our primary 5 numbers and algebra problem solving, so we're going to see the next problem. I'll just read it out. There were twice as many carnations as roses in a flower shop. After selling 50 carnations and 10 roses, there were 3 times as many roses as carnations left in the shop. How many roses were there in the shop at first? Right? So now, as I always say that you read the problem again and again until you understand what is actually given in the problem, right? So for solving this problem, we are going to use algebraic method, right? So if you are not comfortable with the algebraic method and you want the model method, I have given the link in the description for the model method. Please feel free to skip this video and watch by clicking the other link. Yeah. So let's go and see how to solve this problem using the algebra method. Yeah. So as a step 1, what is given in the problem? Now 2 types of flowers, right? And because it is compared between these two, what we do is that we write it like a ratio form so that it will be very easy for us to understand, right? So there are carnations in the shop, right? And at the opening of the shop, right? So there are carnations and there are roses, right? Carnations is to roses, right? So now, because we are going to use the algebra method, right? So let's see, at the starting, when the shop was opened, there was 2 times carnations as the roses. So it is 2:1. The roses, if the roses were 1, the carnations were 2, right? So we don't know how many roses and how many carnations were there. So what we do is that when the shop was open, we take the count as X, right? And then this side as well X. So for every 1 X, there were 2 X, which means for every 1 rose, there were 2 carnations in the shop when the shop was opened. Now there was a sale, right? During the sale, what happened was the carnation was sold 50 and the roses were sold 10, right? 10 roses were sold. So both sides they were reduced, both the side they were sale, so the number got reduced. So after the sale, what happened was, right, the roses became more. So because it is changing, right, the roses were 3 times as the carnations, which means the carnation was 1 and the roses were left 3 times, right? 3. 1:3. So for every 1 carnation, there were 3 roses left in the shop. So now because it is after the sale, both the value have changed. So after the sale, what we take it is we take it as Y count. Yeah, the count as Y. So for every 1 Y, there were 3 Y. For every 1 carnation, there were 3 roses in the shop after the sale. Yeah. So now you see here, let's make an equation using all this side, right? This side is all carnations, this side all roses. So right, so after initially there were 2x of carnations and then 50 were sold off, then you are left with 1 Y of carnation. So let's write that. So 2x minus 50 is equals to 1 Y, right? 1 Y. So now same thing goes this side. Initially there was 1x, x number of roses, and then 10 roses were sold off, then you're left with 3 Y times 3 times Y count of roses, right? So let's write that as an equation as well. So initially there was x, so 1x minus 10 equals to 3y, right? So now for the algebra method, what do we always do is we see how we can simplify it by replacing certain values and things like that, right? So between these two equations, you see the right side, you have this is 1y and this is 3y, right? So what we can do is we can just we can take this value here, right? We can take this value here, and because it is 3y, we know the value of 1y. We know the value of y. 1 time y is actually y. So 3y we know already, right? So what we do is we just replace the value. Y is equals to this much, we know. So in here what we do is instead of y, we just write this one. Yeah, we just write this one. So we are just going to substitute the value. Yeah. So which means x, right, minus 10 equals to 3 times 2x minus 50. 2x minus 50, right? Yeah, so far clear? Okay, so now let's simplify this side of the equation, because there's a bracket and there is a number outside. So just to make everything only look like x and another value, let's just simplify it further. So we just multiply this 3 with this one and then 3 with this one as well, right? So that we remove the bracket. So x minus 10 equals to, this is positive 3 and then this is positive 2. So the end result will always be positive. So 3 times 2 is 6. 6x, and then this is positive 3, this is negative 50, right? So positive times negative, it's negative as per the rule, right? So it is negative, and then 3 times 50 is 150, right? Right. So now you see this one is equals to this one, which means this one is equals to this one as well. So we can, for our convenience for solving this issue, what we do is we write it reversely, which means 6x minus 150 equals to x minus 10, right? So there's nothing have changed, no value have changed, just that this one is equal to this one, which means this one is equal to this one as well, right? So that's why we have written the 6x minus 150 here and then x minus 10 on this side. Yeah. So now what we do is, there are many ways to simplify from here by whatever the less number of, let's like first simplify the x, right? So because both sides we have x, we need to make sure that only one side there is x, right? And the other side it is only numbers. Yeah. In other words, if you add a same value to both the side, right? Both the side, same number or same value to both side, the entire equation, the equality is still maintained, right? So which means, like if you're adding a x here and a x here, which means the equal is still, I mean both the side are still equal. It remains same, right? So which means in this case what we will do is, because we want to remove the x from one side, what we do is, this is a positive x. So what we do, we just do a negative, right? We just subtract another x from here, right? So which means 6x minus 150 equals to x minus 10, right? So we are just subtracting same value on both sides. So which means the equation is entirely not changed. Yeah, it is still equal. So this one will become like here 6x minus x becomes 5x, right? Minus 50, 150 equals to x minus x is 0 minus 10. So this side we are left with 10, right? So now you see here, like this side 5x minus 150 equals to minus 10. So which means like we can add 150. If we add 150 this side and 150 that side, still the equation remains as it is. The equal sign, the equality is still maintained, right? Which means 5x minus 150 plus 150 equals to minus 10 plus 150, right? Because we are just adding 150 both sides, the value is unchanged. Yeah, the equation is unchanged. So now if we simplify, so 5x, this 150, this is minus 150 plus 150, yeah, so this one becomes 0. So 0 plus 5x is 5x, right, equals to minus 10 plus 150, yeah, so which is 140, right? So now for x, to find x, what we do is, right, equals to, the 5 goes to the right side, right, we divide the 140 using the 5. So 140 divided by 5 is equals to how much? Let's see. 140, 5. So in the 1 there is no 5, so take the 4 as well, which is 14. In 14, 2 times 5 is 10, and then remainder is 4. We have 0 here, bring down the 0, right? And then in 40, how many 5s we have? Yes, 8 5s we have. 8 times 5 is 40, so the remainder is 0. So the x value is what? Yes, 28. So what we need to find? The initial number of roses. The initial number of roses before the sale was 1x, 1 time x, right? As per the problem, 1 time x. So what we have found is 1 time x is equal to 28. So that is the answer. We're done actually. So the roses were 28. Yeah. So that is the answer. Right guys, so this is whatever I have explained here. This is another way of solving the problem, right? So this one can be done in different ways, so which I will be explaining in different maths and different ways, so that you get all the ideas in my videos, right? Okay, so fine, we are done guys. Okay, so thanks for watching, and if you like the way that I'm teaching, please subscribe to my channel and also press the bell button so that you don't miss out any of my videos. Yeah, and also please make sure you share the link with your friends. Yeah, thanks for watching. Let's catch up again in another video. Thank you.